Hello everyone. In today's session, we'll be learning about ARM registers. Okay. In ARM architecture, registers are crucial for storing data, addresses, and controlling program execution. Understanding how these registers are organized and how they behave is essential for writing efficient low-level code. If we consider ARM, it has 16 primary registers labeled R0 to R15. These are split into general purpose registers starting from R0 to R12, special purpose registers such as R13, R14 and R15. Each register here is 32 bits wide in standard ARM, that is ARM7 architecture. General purpose registers, that is R0 to R12, can be used to hold data, address or intermediate results. They are considered orthogonal, which means that you can use them interchangeably in most instructions. For example, if you consider instructions like add, move, etc. If initially you have used registers R1, R2, R3, that is add R1, R2, R3, you can replace it with any other registers between R0 to R12. Okay. Next we have special purpose registers. Registers R13 to R15 have dedicated roles and are not orthogonal. R13 is nothing but a stack pointer. It points to the top of the stack, used during function calls and interrupts. R14 is a link register. It stores the written address when a function is called. Okay. For example, branch with link instruction, BL. Okay. Then we have R15 register, which is a program counter. It holds the address of the next instruction to be executed. Okay. Modifying it changes the control flow. These registers should not be used like general purpose registers. Using them incorrectly can cause unpredictable behavior or crashes. Then we have program status register, that is, in addition to R0 to R15, ARM includes two important status registers, one called CPSR, one more called as SPSR. CPSR is nothing but current program status register, while SPSR is nothing but saved program status register. Let's see about CPSR. This CPSR is always accessible. It holds flags like N, Z, C, V, processor modes, interrupt masks, and state information, that is whether the system works in ARM mode or thumb mode. It is structured into 4 fields, each 8 bits, that is flags, which has conditional codes like N, Z, C, V. Then we have control, which has mode bits, state interrupts, etc. Then lastly, we have status and extension, which is reserved for future use. If you consider SPSR or saved program status register, it's only available in privileged modes like FIQ, IRQ, supervisor mode. This SPSR is used to save CPSR during exceptions so that it can be restored after handling. Then we have banked registers, that is, in privileged modes, certain registers are banked, meaning each mode has its own copy. For example, FIQ mode has its own R8 to R14. This enables fast context switching without saving and restoring shared registers. Then we have the concept of active registers. In case of user or system mode, R0 to R15 along with CPSR, which constitutes 17 active registers. But in case of privileged modes, since it also has SPSR register, R0 to R15 plus CPSR plus SPSR gives total of 18 active registers. Okay, so these are few things you need to know about ARM registers.